Hello folks, so we're going to finish chapter 7 today. We're going to do 7.6, which is connected particles. Alright, so we're going to label up, so they've given us a diagram which is quite nice, so we're just going to label up and just read through what it says. So we've got two particles, P and Q, of masses 5 kilograms and 10 kilograms. So we know that that's got a weight of 5g and that's got a weight of 10g. Respectively connected by a light inextensible string, so that means the accelerations are going to be the same. The string passes over a small smooth pulley, so that means the tensions are going to be the same, so we'll call that T, we've got a reaction force, so the particle doesn't sort of fall through the plane, and then they've said it's fixed at the top of a rough inclined plane, so we'll just sort of write on here that we'll draw on here that it's rough. Don't have to do this, just helps sometimes. So we've got friction opposing the motion, so it's going to go downwards because it's being pulled up the plane. So if you want to sort of label the fact that the acceleration for particle P is going parallel and up the plane, and then the acceleration for Q is going vertically downwards. Okay. P rests on the inclined plane, Q hangs on the edge of the plane with a string vertical and taut. The plane is inclined to the horizontal at an angle alpha, where tan alpha is equal to 0.75. So if I just draw a nice little triangle, oh, that's terrible. We've got alpha there, so if it's 3/4, then I know that that is 3, that's 4, and then I can use Pythagoras to find out that that's 5. Okay. Coefficient of friction between P and the plane is 0.2, so I'll just put that there to remind me. So I think I've got everything now, so I can start. So they want us to find the acceleration of the system. Okay, we could find the acceleration of Q, but it would just be in terms of T, or we could find the acceleration of P, but this time it would be in terms of T and friction. So what we could do is if we found sort of equations for both of them, then we've got 2 equations and 2 unknowns, so we could just use simultaneous equations. However, we need to figure out what friction is first, otherwise we're going to have an extra unknown. Okay, so to find out friction, we need to find the reaction force. So the first thing I would do is resolve perpendicular at P. So I've got, it's not moving in this direction, so I can just say they're equal to each other. So I've got R is equal to 5g cos alpha. Use my horribly drawn triangle. I can see that cos alpha is equal to 4/5. So 5g times 4/5 gives me 4g. Okay, so it doesn't really matter which one I pick first, whether I do Q or P. I'm going to do, let's do Q. So I've got, I'm going to resolve downwards at Q. So I've got 10g, and then because it's moving, I'm going to use F equals ma minus T equals 10a. I'm going to rearrange it because I know that I want to sort of cancel out the tension, so I'm just going to rewrite this as T equals 10g minus 10a. Okay, and then if I resolve parallel at P, then I've got, so following the sort of motion of the particle, I've got T minus my friction, and don't forget about the weight, minus 5g. You can add in your angle if it helps you. Sine alpha, and then again using F equals ma equals 5a. So I know what the reaction force is now, so I can substitute in my friction. So I've got T minus 0.2 times 4g minus 5g. I know sine alpha is 3/5, so I can pop that in there as well. Equals 5a. And then I can substitute my tension in there as well. So I've got 10g minus 10a minus 0.8g minus 3g equals 5a. So if I just sort of collect my like terms, so I've got 10g minus 0.8g minus 3g is going to give me 6.2g equals 15a. So I can therefore say that a is equal to 6.2g over 15. And then that, if I pop that into my calculator, gives me 4.1 meters per second squared. And that's to 2 sig figs, sorry. Okay, so that's part A.